another episode of Learning sCrypt tutorials. In this video, I'm going to cover the data types offered by sCrypt. So again, let's also again start with the official website, sCrypt.io. From there, we can click documentation. We are land in sCrypt language reference. So then we can go to syntax spec, and we can see there's a section called types. So first, let's talk about the basic types. So these are the primitive types. So it's not very different from many other mainstream languages. So you have a Boolean type, which you can have literal, true, or false. You also have an integer. So it's worth noting that the integer type here is signed, and also it can be of arbitrary length. So it's very similar to big integer in some other languages. For example, it can be in a decimal format. It can also be in hex format. And there's another type called bytes. So basically, it's a variable length of an array of bytes. The literals can be represented by prefix b followed by single quote. So these are usually can represent the raw bytes. So we are going to cover more later. So besides the primitive types, we also have so-called composite types. So including two. One is the so-called array types. So an array is just a fixed size of a list of values of the same type. So it's noteworthy here, the array types in sCrypt has to be fixed size. You cannot have dynamic sized arrays in our case. So how do you define your array literal? So basically you write the type first, and then you write the square bracket, and within it you write the size. So in this case, you can say B can be initialized with three Boolean expressions, also using square bracket. You can also have multiple dimension arrays. For example, you can have an array of 2 and 3. So basically, it contains two arrays, two elements in this D array, and each of the element is itself an integer array of size 3. So this is a declaration here. So in special cases, when is known in advance, the right-hand side of when you initialize a array, the size, the dimension of the array can be omitted, can be skipped, as you can see here. There's also a helper function, basically called repeat. So sometimes you want to, let's say, initialize an integer array to be all 0. So you can say repeat. Let's put all 0 and provide the size of the array. So you can using this very helpful utility function quickly. So also you can using index. Basically, you can access it with an array at a certain place with the index operator, which is very common in many other languages as well. So another composite type is a so-called struct type. So how do you define a structure? Basically, you again using the struct keyword followed by the name of the struct, and then using bracket. Within it, you write all the fields in this struct. So you can then reference each field by using the dot notation as in many other languages. You can also compare two structs. So two structs are equal if and only if all the fields, all the corresponding fields are equal. So after we talk about basic types and composite types, another types which we call the domain-specific subtypes, we leverage this for adding more type security into our system. So what are some of the examples? So for example, we have previously we mentioned we have this primitive type called bytes. So we also introduce a subtype of it, for example, called a public key, pub key. So basically this represents a typical Bitcoin public key, a type. So all the subtypes of bytes can be used where bytes can be used, but not vice versa. So for example, how do you convert, let's say convert a bytes, raw bytes type into public key type? You're using this typecast. Let's say this B, follow this is a literal bytes, right? So you can convert it using the typecast. So now you got a public key type. Again, all the places where you can use bytes, you can use public key type. So besides the public key, we also have a lot of other very specific types that's very unique to Bitcoin domain. For example, you have often you have signatures. You also have you do a lot of hash. For example, SHA-256, or you can even do SHA-1. So each SHA operation also give you a specific type of that SHA type. I think we also have some other type which for this video I'm going to skip. So another one, subtype of integer. So in this case, it's a private key. So for private key, it is you can use it as if it's an integer, but not vice versa. Okay, I hope this video is useful, and I hope to see you next time. Thank you.